Okay, let's get started with parabola. So there's a fair amount of information here to start with. So let's just read it together. It says, let's talk about how we define a parabola. So a parabola is a set of all points x, y in a plane that are equidistant from a fixed line, the directrix, so that would be this here, and a fixed point, the focus. So every single point is has the same distance from the focus as it does to the directrix, as outlined here. The midpoint between the focus and directrix, so this distance here is the same, is the vertex. The axis of the parabola, or sometimes referred to as the axis of symmetry, is the line that cuts through. So we have two different standard form equations for a parabola. One with a vertical axis and one with a horizontal axis. As we look at these, you'll notice really the only difference here has to do with the location of x and y. So for our vertical axis, the x portion is squared. For our horizontal, the y portion is squared. Other than that, it's basically all the same. So you're just switching the location of x minus h with y minus k. So let's talk about what these letters mean. So HK represents our vertex. P represents the distance from the vertex to the focus. So P is that distance here. It's also the same as the distance to the directrix. It's important to remember that 4P there, that 4 is there as we're trying to graph or write equations. Okay, so we'll try and keep that in mind here, and we'll start graphing. If you haven't, I would recommend just kind of taking in some of these images here, trying to think about how they relate to the equations. So we have a few different things to do here. For each of these problems, it says find the vertex, focus, and directrix of the parabola and sketch its graph. So as I'm looking here, the first thing I'm noticing is that our x portion is squared. So when we have x squared, the general formula is x minus h squared equals 4p times y minus k. And this is going to be a vertical parabola. So it's going to look like this or like this, because the x portion is squared. So as I'm looking here, let's try and get it set up in this form. So the first thing we can do is we can just kind of flip sides. So put 1/2 x squared on the left and y on the right. And I'm noticing you can't have a multiplier here with your x. So we're going to multiply both sides by 2 to get x squared equals 2y. So now it's starting to match up with what we have here. So as I look at this form, let's again try and kind of get things in the right order. So we have x squared. So we could rewrite that as x minus 0 squared. Same here as y minus 0. So now it's looking like it's really starting to match up here. So we would have HK would be 0, 0. So that would be our vertex. Remember, as we're thinking about the focus, to find our focus, we want to figure out what our p-value is. So as we look here, we have this 2, and it matches up with 4p. So to figure out our p-value, we set 4p equal to 2. So divide by 4, we get p equals 1/2. So we have a p-value of 1/2. So if we think about this here, something I suppose I failed to mention particularly was that when our p is greater than 0 or positive, it's going to open up. When it's less than 0, it's going to open down. And so as we're thinking about this here, our p is positive, so it's going to open up. So let's think about our vertex. So our vertex is at the origin at 0, 0. We have a p-value of 1/2. So remember, p represents the distance from your vertex to the focus as well as to the directrix. And if it opens up, that means our focus will be above because it's going to wrap around that focus. So the distance is p, which is 1/2, so it's 1/2 above our vertex, or 0, 1/2. Similarly, our directrix would be the same distance, 1/2 below. So this would be our line here at y equals negative 1/2. And then the rest of our parabola would wrap around here. We could plug in some points, try and get things a little more accurate. Like if we plug in up here 1 for x, we would get 1/2 for y. And since parabolas have an axis of symmetry, it would match on the left. If we plug in 2 for x, we get 4/2, which is 2. So something along the lines of this here. Okay. All right. Let's look at number 2. So again, to start, you probably want to identify, well, what is which value is squared? So is it vertical or horizontal? So our x value is squared, so again, we're going to have a vertical parabola, so we want to match up with this form. So we want to get our x portion squared, and then have our y portion on the right. So as we look here, one thing to do is, again, notice you cannot have a multiplier there on your x. So let's factor out a -1/2. So -1 divided by -1/2 would give me a +2. 1/2 divided by -1/2 would give me a -1. Right? Yeah. Multiply both sides by -2. So then that we have our x portion by itself. So as we're looking here, we need to get this x in parentheses squared. So we can't really do that here. If we can't really factor this into something that will multiply to -1 and add to 2. So we want to think about this in terms of completing the square. So remember, to complete the square, this is something you touched on last week, we need to figure out what b over 2a is. So our b value is 2, our a value is 1. So we have 2 over 2, or just 1. And whatever b over 2a squared is, so in this case it'd just be 1 squared, which is 1, that's what we add here. So if we're adding 1 to this side, we should also add 1 to the left side. And this would factor into x plus 1 times x plus 1. Or really, it's just x plus whatever your b over 2a is squared, to your b over 2a is, and then square it. -2y plus 1. Got to have our x by itself, so let's add 1 to both sides. So we'll have, let's put that over here. So we have -2y plus 2 equals x plus 1 squared. I'm going to flip them around just because I like to have it matching up well. And then we need to make sure our y is by itself. So let's factor -2 out here. So we get y minus 1 there. Okay, long process, but we're in our standard form now. So we can identify our vertex, hk. So h would be -1, k would be +1. So we can start there at -1, 1. Next, we should determine our p-value. So from this problem, 4p would be equal to -2. So divide both sides by 4, we get p equals -1/2. P is negative, so I know it's going to open down. And our p is -1/2, so that'll be the distance to our focus. So the focus will be 1/2 below, so -1 at and 1/2. The directrix will be 1/2 above. So we get y equals 1.5, or 3/2. If we want to add in some more points, we can. We can plug in some x values here, so like 0 would be a nice one. So 0 minus 0 plus 1/2, so we just get 1/2 there. And you could do some more, but it's not required. Just have a nice general picture. Okay. So kind of a lot here, but the general idea is we want to get it inside of the general form, or the standard form, excuse me, of the equation of a parabola. So to start, first figure out what your standard form is. So figure out which part's squared, then go ahead and continue from there. Once it's in standard form, then you can find that p-value, so you can find your focus and directrix, you can find the vertex using hk, and so on. All right, we've got a couple more here. Why don't you try number 3 on your own, then we'll do number 4 together. So pause the video, give it a try. Okay, we're back. So this time our x is squared, so we should have a vertical parabola again. So we want to match that same form that we have been. So our x needs to be by itself on the left, so let's subtract 6y from both sides. We could rewrite that like so. So our vertex is at 0, 0 again. Think about our p-value. So we would have 4p equals -6, so divide both sides by 4. We get p equals -3/2. So p is negative, so it's going to open down. And our focus will be 3/2 below our vertex. So it'll be at 0, -3/2. Our directrix will be in the opposite direction at y equals +3/2. And then we can go ahead. You could plug in some values if you'd like. I'll plug them in up here because that looks easy. So if I plug in 0 for x, I'm going to get, or wait, what am I doing? Oh, well, yeah, we already know it's 0, 0. So let's plug in 1 for x. So if I plug in 1 for x, I get 1 equals -6y, divide both sides by -6, I get -1/6. It would match on the other side. If I plug in 2, I'll get 4 equals -6y, divide both sides by -6, and I'll get -2/3, so a little more down there. Okay, so something along those lines. Okay, all right, last one here. So this is our first one where we have a horizontal parabola because our y value is first. So the equation for horizontal is y minus k squared equals 4p times x minus h. Notice it's always x minus h and y minus k. Those are your key portions. If it's horizontal, the y part squared. If it's vertical, the x part is not, or the x part would be squared. So it's just those two that are switching places. So let's subtract this y minus 5 from both sides, like so. And we're already in our standard form. So our vertex here would be +5, because it's always h and k. So h with x, k with y, and -4. So 1, 2, 3, 4, 5, 1, 2, 3, 4. Next, let's figure out our p-value. So we have 4p equals -1, so p is -1/4. So let's think about what that means. With our horizontal parabolas, if p is positive, it opens to the right, negative to the left. So it's going to open up to the left, so that means our focus will be to the left, a distance of 1/4. So the y value stays the same. The x value will be 1/4 to the left. So from 5 to 4 3/4. The directrix will be 1/4 to the right, or x equals 5 1/4, because x would be a vertical line. Next, we want to figure out how to graph this. So let's plug in y values, because that's where things are going to mirror. Let's just start with, I don't know, 4 maybe? So if we plug in, or wait, what would that be? 1, 2, 3. So let's try 3 for y. So we'll have, or -3, excuse me. So we'll have -3 plus 4 squared equals -x minus 5. So that's 1 squared is 1 equals -x plus 5, just distribute that negative. Minus 4 is -4 equals -x. So x equals 4. So when I plug in 3, I get 4. So 4 for x, 1, 2, 3, 4, 3 for y. And the same would match on the other side. So that helps me give like at least a little bit of an idea of kind of the narrow or wideness of my parabola. Okay. And there we have it. That's how we graph parabolas. So you're really just using, more than anything, the standard forms and plugging things in accordingly.